In our last lesson, we looked at classes and objects, and we were able to create and instantiate a capsule. This time around, let's go ahead and look at a very important concept called loops. What if we wanted to instantiate all these capsules? And to do this, we have to do this manually, right? So a loop is a special kind of conditional statement that has the ability to execute more than once. Right, so a very common use is to actually process a value or say an array, and then the loop will stay the same size, and then you can increase the value of that loop. So let's go ahead and create a script to show an example of how we can use that for loop. So right now in my scripts folder, I'm just going to create a new, let's go to our component, our assets, create C# script, and let's just call that using loops. And I'll just double click that to open that up. So now that we've opened that document, let's go ahead and see the syntax for creating a for loop. So what I like to do is to pass this into a function. So I'm just going to call this a void for loop. And let's just go ahead and drop this down like that, like so. Now the syntax for a for loop is simply we use the keyword for, and then we have an initializer that's usually set to a default value. So you can have an initializer like set to 0. Then we actually have a boolean value, but usually we'll call this a test, right? That will return a boolean value, and then we actually increment that value, and we also close that with a colon, and then we can have our curly braces. So that's the syntax for a for loop. I'll just pass this at the top to actually keep that in one line. So to actually use a for loop, let's go ahead and do something. So I'm just going to say a float I. So I'm just creating an empty float variable, and I'll just say a float ammo, and I'll set the value of the ammo to 10. And we're not using that, so that's the reason why it's squiggly. So let's go ahead and create our for loop. So let's just say creating our for loop. And simply what this for loop is going to do is to count from 1 to 10 for our ammo. So I'm just going to say for, and I'll pass in my I equals 0. Now I'm initializing my I. And the next thing, I'm going to pass in the value for I. So I'm just going to say I is less than equal to the ammo. Oops, it's ammo that we created right now. And then next, I'm going to increment that value by 1 unit. So that's why we have that I++. And finally, what I'm going to do is to just print out this value as a debug. So we can either say a debug .log, and then we can pass in let's see, the value of I is, I'll just say I is, and then we'll just concatenate the value for I, just like that. So let's go ahead and save our script, and let's call our for loop function and start, because we just want this to run once. So let's say for loop, and what we're simply doing right here is calling our loop, our function. So let's go ahead and save that and jump to Unity. Now the name of our script is using loops, so let's go ahead and attach using loops to say any game object. So let's attach it to our empty game object which we created, and let's go ahead and hide our cube by deselecting the visibility on the inspector. So now we have our empty cube. Let's just go ahead and drag our using loops to our script right here, and let's deactivate the using working with classes. Let's go ahead and save that, and let's just run our script. So right now, when we look at our console, we can see that it starts counting from a value of, so it starts counting from 0 to 10. just like that. So if I go ahead and stop that and run it again, we should see we have our count from 0 straight up to 10. So that means it's increasing this value step by step. So why is this important, and how are we going to use this? So say for instance we wanted to create a range of game objects, and we want to actually specify the distance between these game objects. For instance, if I wanted to instantiate 5 cubes or 3 cubes at a specific distance close to each other, for instance, let me just go ahead and bring out this cube and say we wanted to create another one and another one. So when I select the cube, I'll just use Ctrl D to duplicate that cube, and say we're here. We wanted to create 3 cubes just like this, but then have them at a specific distance. Let's say a distance of 2.5 meters in between. We could just do that once with a for loop instead of creating that, writing that 3 times, using that create primitive 3 times. So let's go ahead and see that as an example. So I'm just going to go back to my C# script, and let's just go ahead and let's create another function, and I'll just collapse this one and just write underneath, I'm just going to call it void creating cubes, because basically what we're going to be doing is creating cubes right now. So now that I have my creating cubes function, what I'm going to do right now is to actually start passing my creating my for loop. So I want this to create 3 cubes and space them. So let's say creating 3 cubes and spacing them 2.5 units apart. So basically I'm going to use our game object.create primitive, and I'm also going to get our local transform and multiply that. So let's see that in action. So first I'm going to create my for loop. I'm going to say for, and I'll create a variable int x. Now if we note in our example here, I actually created the float first, but for a for loop you could actually do it like so. For a for loop you could actually jump in directly, and I'll just add this as a side note. We could do it like so. So we could actually say for, and then we'll just pass in our int I equals 0. Then I is less than or equal to our ammo. Then we could do an I plus plus. We could do it like so, and our script will run perfectly fine, right? We could do it that way also. So let's go ahead and just collapse that and get back in here. So here we're passing the initial value for our variable, and we've called that variable x. So now, x is going to be equal to 0, and then next x is going to be less than or equal to 3, because I want to do this 3 times, and I'll start incrementing. So x plus plus. So basically what I'm saying is, you know what, I'm going to start from 0, and I'm going to add 1 to 0, then add 1 to 1, then add 1 to 2. So once it gets to 3, stop doing whatever is in between these curly braces. Again, we're going to start from 0, we're going to be incrementing by 1, and when that value is equal to 3, we are going to stop. So it means we're going to do it 3 times. If we wanted to do it 5 times, we'll actually pass the value of 5 right here, right? So let's go ahead and just set that to 3, and let's go ahead and create our primitive. So I'm just going to say game object, and we're going to call that our mini cube. It's going to be equal to game object. Whoops. Game object dot create primitive, and then we'll pass in the type for primitive type dot cube. So we could actually create other types. If you wanted to create a capsule, that's totally fine. So what I'm going to do right now is to get the transform for our mini cube and multiply that transform by the value of x. So I'll show you why I'm doing that. So I'm just going to say mini cube dot transform dot the local scale, I'll rather use local position. So I'm going to create a new vector tree. So I'm going to say new vector tree. And right now for my x value, I'm just going to say x, which is my x variable I created right here within my for loop. I'm going to multiply that by a float. Let's go ahead and create a float right here. We could just say a float. Let's say value equals 2.5 f. So we don't have magic numbers within our code. So I'm just going to call value, and we're going to also multiply this by say 0f and 0f by our x and y axes, just like that. So let's go ahead and save our script, and let's not forget to call our creating cubes method right here. So I'm just going to go to jumpstart, and I'll just say creating cubes. And one way to, I can comment this out. So this is not going to be run when we run this script. So let's go ahead and jump into Unity, and let's clear our console. Like so. And let's go ahead and just play our scene. And we can actually see we have them created a bit kind of like far away. Where are they? Just click on one, and let's actually see this. So the cube is actually going underneath our game object, so it's not allowing us to see it. So let's go back to our game view, and if we actually get rid of our scene, we can actually see this because it's underneath, right? It's underneath. What we could do is to set a value for our y, so we can actually have our cube high. So let's go back to Unity. So basically what we want to do is to raise the value of our cube. So let's go ahead here in our script, and for our y value, let's just say float height, and we're going to set that to 3.0 f, just so we can have that above the floor. And right here we'll just say and set this value to height. Now the height is going to remain the same for each of the cubes that's created because we're not multiplying that by any value. So if we're multiplying this value for our x-axis by this x, remember x is going to be increased by 1. So we're going to have 2.5 plus 1 plus 1. So we're going to have 2.5, 3.5, and 4.5, just like that. So let's go ahead and save that. And let's run our script again, and hopefully we're going to have it above this time around. So let's go ahead and clear this, and let's play our scene. So now we can see we have those cubes arranged above our floor. So that's one quick way, and that's one very important use of loops. So we also have another very powerful way of creating game objects, and we'll be looking at that in future lessons. Thank you very much guys for watching, and I'll see you in the next lesson.